Hello friends, welcome to our channel The Quantum Quest. So in this video we are going to discuss about vectors. Vectors are quantities with magnitude and direction. We can represent a vector graphically by an arrow showing both its scale length and its direction. By using vector notation, physical laws can often be written in compact and simple form. Newton's second law in 19th century notation was Fx equals max, Fy equals may, Fz equals maz. In modern vector notation, we can write this law as F vector equals ma vector. Now, modern vector notation was invented by physicist Willard Gibbs of Yale University primarily to simplify equations. Magnitude or modulus of a vector is represented by mod A. Next, types of vectors. Our first type is equal vectors. If two vectors have equal length and same direction, they are called equal vectors. These two vectors will be parallel. Now, opposite vectors or anti-parallel vectors. Vectors that have same magnitude but are in opposite direction are called opposite vectors. These vectors are anti-parallel. Now, the third vector is unit vector. A vector having unit magnitude, and unit magnitude means its magnitude will be 1. A vector having unit magnitude and same direction as that of the given vector, then that is called unit vector. It is represented as a hat for a given vector A. Now a hat is equal to vector A divided by its magnitude. The unit vectors along x, y and z axis are I, j and k. Now position vector. A vector drawn from origin to a fixed point. It is used to specify a particular point and is unique for each point. So a position vector is a vector drawn from origin to a fixed point. See here. Now this is a position vector in two-dimensional, a 2D plane, and this is a position vector in 3D. It is used to specify a particular point and is unique for each point. Next, triangular law of vector addition. If two vectors are represented in magnitude and direction by the two orders of a triangle taken in the same order, then the third side of the triangle taken in the reverse order represent the resultant vector. Just consider two vectors, vector A and vector B. You have to add these two vectors. So to add these two vectors, suppose consider vector A and vector B. Place the vector B to the head of vector A and their resultant, that is vector A plus vector B, will be the vector drawn from the tail of the vector A to the head of vector B. See, this is the resultant vector R.
Consider two vectors, vector A and vector B. Their resultant is R vector. The angle between vector A and vector B is theta. The angle between the resultant vector and vector A is alpha. Now we have to find the magnitude of this resultant vector as well as its direction. So for that we have to draw a right angled triangle. Okay, so let me draw a right angled triangle. I have drawn the right angled triangle, triangle PNS. Now we need to find the magnitude of R vector. So for that we have to apply Pythagoras theorem in triangle ONS. Applying Pythagoras theorem, we will get ON square plus SN square equals R square. Okay, so we have to, this is our first equation, this is our equation number 1, and we have to find the value of On and Sn. What is On? On is the On is OP plus Pn. On is OP plus Pn. What is OP? OP is the magnitude of vector A. And what is Pn? Pn is B cos theta. This side is parallel to vector B, so this side has the magnitude of vector B, and this angle will also be theta because these two sides are parallel. So B cos theta is equal to Pn. When we take the cosine of this angle, we will get Pn by hypotenuse, Pn by B. So cos Pn is equal to B cos theta. Now, so On is equal to A plus B cos theta. Now what is Sn? Sn is B sin theta. How we will get Sn? See, when we take the sine of this angle theta, we will get opposite side Sn by hypotenuse. Hypotenuse is B, so Sn is B sin theta. Sn is B sin theta. Now we have to substitute these two values in our equation number 1. So R square equals A plus B cos theta the whole square plus B sin theta the whole square. Now R square, on expanding this, we will get R square equals A square plus 2AB cos theta plus B square cos square theta plus B square sin square theta. Now we can take B square from these two terms as common. So we will get in brackets cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. That is a trigonometric identity. So we will get R square equals A square plus 2AB cos theta plus B square. So R is equal to root of A square plus 2AB cos theta plus B square. So we got the magnitude of the resultant vector. It is root of A square plus 2AB cos theta plus B square. Now we need to find the direction of the resultant vector. That is, we have to find the angle alpha. So how we can find the angle alpha? See, when we take a tangent of this angle alpha, we will get tan alpha equals opposite side Sn by adjacent side On. Sn by On. And what is Sn? Sn is B sin theta. B sin theta. And what is On? On is A plus B cos theta. A plus B cos theta. Now alpha, what is angle alpha? Alpha is tan inverse of B sin theta by A plus B cos theta. So this is our direction. And here this is our resultant vector magnitude. Now we need to learn some special cases, that is when the angle theta is 90 degree, 0 degree and 180 degree. So first we will learn when angle theta is equal to 0 degree. When angle theta is equal to 0 degree, our resultant vector's magnitude will be r is equal to what was the formula, a square plus 2ab cos theta plus b square. So r is equal to, when theta is 0 degree, it is a square plus 2ab cos 0 plus b square. Cos 0 is 1. So this one will become a square plus 2ab plus b square. Now this can be written as a plus b the whole square. So the resultant is equal to square root of a plus b the whole square. Now when this term comes outside of the square root, we will get r is equal to a plus b. So when the angle theta is 0 degree, the resultant is maximum. The resultant vector has its maximum magnitude, a plus b. Now when angle theta is equal to 90 degree, what will be the case? When theta is equal to 90 degree, r is equal to root of a square plus 2ab cos 90 plus b square. What is cos 90? Cos 90 is 0. So this one will become under root a square plus b square. So this is when the angle theta is 90 degree. When theta is equal to 180 degree, and theta is equal to 180 degree, the resultant vector r vector's magnitude is square root of a square plus 2ab cos 180 plus b square. Now this is equal to, cos 180 is minus 1. So this one will become square root of a square minus 2ab plus b square. Now this can be written as square root of a minus b the whole square. When this term comes out of the square root, you will get r is equal to a minus b. So when the angle is 180 degree, that means the two vectors are anti-parallel, then their resultant will have minimum magnitude. So in today's video, we have learned about vectors, types of vectors, triangular law of vector addition, and how to derive an expression to find the magnitude and direction of the resultant vector. So that's all for today. Thank you.